Hello all. So this is Yadagiri working as assistant professor in Marri Laxman Reddy Institute of Technology and Management in EE department. So today my topic is mesh analysis in electrical circuit 1. So in previous lectures we have discussed about network reduction techniques. So in this lecture I am going to deal the concept of mesh analysis. So here in network analysis we are going to deal with two concepts. One is mesh analysis and nodal analysis. So mesh analysis and nodal analysis are the basic important techniques used in finding the solutions for a network. So these are the two networks important techniques. So they are used to find the solutions of a network. So solutions may be the current in the network or voltage across any network. So we can find with the solutions with the help of mesh analysis and nodal analysis. So the suitability of either mesh analysis or nodal analysis is to a particular problem depends mainly on the number of voltage sources and current sources. So that means if you can apply what is the way, which method we are going to apply. So for that we are going to discuss, we are going to take how many number of voltage sources are there and number of current sources are there in a circuit. Based on that we can choose that mesh analysis or nodal analysis. So that is the point here. So if a network has large number of voltage sources, for example, if we can take, if the network has large number of voltage sources, then it is used to use the mesh analysis. In the same way, if it is there are many current sources are in a circuit, then it is we are converted that into voltage sources, and then after that we have to use the mesh analysis. So here requires all the sources in a circuit be voltage sources. So for example, if a network is having large number of voltage sources, it is useful to use mesh analysis, as this analysis is requires all the sources in the circuit be voltage sources. So therefore, if there are any current sources in the circuit, they are be converted into equivalent voltage sources. So if the network is containing current sources, then we have to replace that into, or we have to convert that into equivalent voltage sources. If on the other hand, if the network has more current sources, then nodal analysis is more useful. So this is the concept here. So now mesh analysis is applicable only for planar network. So here this mesh analysis is applicable to only planar networks. It is not applicable for non-planar networks. Then what is the planar networks? We will see now. So for non-planar networks, the mesh analysis is not applicable. A circuit is said to be planar if it can be drawn on a plane surface without any crossovers. Without any crossovers, we can say that circuit is a planar circuit. Now let us see what is non-planar circuit. A non-planar circuit cannot be drawn on a plane surface without a crossover. So now we will see that what is the difference between the planar and non-planar graphs with the help of the diagrams here. So here we will see the three diagrams here. So in the first circuit we can say figure A is a planar circuit because here no crossovers are there, and figure B is a non-planar circuit. Why? Because the crossovers are there here. So you can see here this is the one crossover and this is another crossover is there. So we can set this type of circuits we can call it as a non-planar circuits. And of course the figure C is a planar circuit, but you can see here it is not a crossover here. So it is connecting in between this point and this point here. So it is not a non-planar network. So figure C is a planar circuit, but which looks like as a non-planar circuit. So it is already been discussed in that. So what is meant by loop? So loop is a closed path. Loop is a closed path. So mesh is defined as a loop, so which do not contain any other loops within it. So that is the definition of a mesh. So to apply mesh analysis, our first step is to check whether the circuit is planar or not. First we have to check this condition. Second one, and select the number of mesh currents. Select the number of mesh currents in the circuit. Finally, write the Kirchhoff voltage law equations in terms of unknowns and solve them, which leads to final solution. So these are the steps for applying the mesh analysis. So once I am repeating here, so what is the first point here? So first we have to check whether the circuit is planar or not. Second one, we have to select the number of mesh currents in a circuit. And finally, we have to write the KVL equations in terms of unknowns and solve them, which leads to the final solution. So this is the steps for mesh analysis. Now let us see one simple diagram here, and we can solve how to solve this problem with the help of the mesh analysis. So first we have to see here. So this is a simple network is given. So here I am going to indicate that two loops first. So first I am starting from A. So A, B, E, F, A. It is forms one loop here, and from B, C, D, E, B, and it is also forms one loop here. So by observing the circuit, first we have to identify how many number of loops are there in a circuit, and first step is we have to check whether it is planar or non-planar. Second step is we have to identify how many number of loops are there, and after that we have to assign the loop currents. So here I am assuming the two loop currents, that is I1 and I2, with the directions as indicated here. So either we have to take clockwise or anti-clockwise. So direction doesn't matter, but we have to take all the loops in the same direction only. So here, so first we have to consider first loop, that is A, B, E, F, A alone. So we observe that current I1 is passing through R1. So R1, and I1 minus I2, the difference of two currents, that is I1 minus I2, is passing through R2. So by applying Kirchhoff voltage law, so we can write the equation as, so Vs is equals to, here I am writing here, so that is, so I am starting from A, so that is I1 into R1 plus, here this for R2 branch, for this branch here we are seeing two currents here. So that means here I am going to write the difference of two currents. So that is, for first loop I can take that as a I1 first. So I1 minus I2, the difference of currents into that resistance. So minus Vs is equals to 0. So this is the application of KVL in first loop. So apply KVL in loop 1. So if we can rearrange this one, we are getting as Vs is equals to, so I am separating all I1 terms here. So that is R1 plus R2 of I1, next minus R2 into I2. So let us take this equation number 1. In the same way, we are going to apply KVL in loop 2. So here I am going to apply KVL in loop 2. So here I am considering the second loop here. So the second loop is from B, C, so B, C, D, E, again B. So in this loop I am going to apply KVL here. So I am starting from B, so that is I2 R3 plus I2 R4 plus, so here for writing the KVL for this particular branch, see this current is common, this branch is common to two currents here. So first, which loop we have taken? So first we have to consider that current. So that next we can consider the second loop current. So that is I2 minus I1. So whenever we are considering this is as our primary loop, so first we have to take this I1 and I2. I2 minus I1 of current is flows into this branch. So that is I2 minus I1 into R2 is equals to 0. So again here we are rearranging the I1 and I2 terms. So then we are getting as minus R2 into I1. So here I2 is there, here I2 is there, here I2 is there. So plus R2 plus R3 plus R4 into I2, which is equals to 0. So let us take the second equation. So likewise, if we have the n number of loops are there, so we can apply the each and every loop. We have to apply KVL and we have to write the equations in terms of unknowns. And after that, we have to solve the equations. Then we are getting the unknown values. So in that way, we have to find the loop currents, that is I1, I2, and if n number of loops are there, then we have to find n number of equations. So let us see whatever we have derived in the previous. So that is Vs is equals to I1 R1 plus I1 minus I2 into R2. So we can see here. So that is R2 is equals to minus I2. So that is Vs is equals to I1 R1, and here it is. Similarly, we have seen for the second equation also. So we have to solve for the second equation. So if we can solve the equations 1 and 2, then we are getting the I1 and I2 from this relation. So after solving the equations 1 and 2, then we are getting I1 and I2. So once we know the I1 and I2, so it is very easy to find the branch voltages. Each and every branch voltage we are going to easily find. That is the way to find the loop currents by using mesh analysis. So here we have to see one simple expression here. So general expression. So here if you can see here, if the general formula we are seeing here, number of equations, that is number of loop equations we can find with the help of the equation. So that is b minus n minus 1. So the number of loop equations we can find with the help of the formula, that is m is equals to b minus n minus 1. What is b? B is nothing but number of branches in a circuit. So number of branches in a circuit, and where n is nothing but nodes, number of nodes in a circuit. So here we can see from this diagram. So first we have to identify number of branches here. So from A to F, one branch is there. So this is one branch. And from A to B, this is one branch. From B to C, it is one branch. From C to D, it is one branch. And from B to E, it is one branch. So totally we are having 5 branches. So B is equals to 5. And we have to identify nodes here. So that is, here we can identify that one node. So more node is nothing but the interconnection of more than 2 branches. So here also one node we have identified here. Here also one node we have identified, and this is reference node or datum node. So totally we are identified as number of nodes is equals to 4. So based on this, the number of linearly independent mesh equations is given as m is equals to b minus n minus 1. So branches are 5 and nodes are 4. So 4 minus 1, it is 3. So 5 minus 3, so it is equals to 2. So that means the number of linearly independent mesh equations we are getting as 2 based on this formula. So now coming to the next topic, that is super mesh analysis. So what is meant by super mesh? Super mesh means in between two loops, if there is any current source is present, then it is very difficult to solve the problem. So it is tedious process. Again, we have to convert that current source into voltage source, and it is taking time consuming. So it is a tedious process. So to overcome that one, so we have to go for the super mesh concept. So now we are going to discuss super mesh analysis. So here in this, for example, suppose if any branches in the network has a current source, then it is slightly difficult to apply mesh analysis straightforward, because first we should assume unknown voltage across the current source, writing mesh equations as before, and then relate the source current to ascend the mesh currents. So it is very time taking process. So this is generally difficult approach. So to overcome that difficult approach, we can go for the super mesh concept, super mesh technique. So here we have to choose the kind of super mesh here. So a super mesh is constituted by two adjacent loops having a common current source. So as an example, we can consider one network here. You can see this network. So in this network, this loop and this loop, so in between these two loops, so we can see one current source is there. So whenever the current source is there, we have to apply super mesh here. So it is very we are not directly apply the super mesh mesh analysis here. Whenever, especially this such type of networks, so whenever we are having the current source in between the two loops, then we can apply the super node technique. So what is meant by super node technique? Let us see now. So example. So here current source I is common to boundary of two meshes, that is mesh 1 and mesh 2. So this current source create a super mesh, which is nothing but the combination of mesh 1 and mesh 2. So it is nothing but it creates a super mesh means what here? So super mesh means the combination of two loops we can consider, and we have to apply KVL for this super mesh analysis. So this is the point. So here it is not applicable. So here whenever the current source is present in between the two loops, so especially we have not going to apply the KVL in this loop and in this loop. So directly we have to apply KVL, and we have to make this as this dotted line, whatever this dotted line indicates. So this forms a super mesh. So this forms super mesh. So after applying KVL to this super mesh, again we have to correlate the relation for this current source. So that is the difference of two currents, that is I1 and I1 minus I2 is equals to I. So after applying the KVL to the super mesh, the second equation we are going to write the difference of two currents is equals to I. So after solving these two equations, and one more loop equation is also there. So after writing these three loop equations, we have to find the unknowns of I1, I2 and I3. So this is about the concept of super mesh. So now we will see problems on mesh analysis. So here I am going to take one simple problem here. So first, what is asked here? So write mesh current equations in the circuit and determine the current. So we have to determine what are the mesh currents, and we have to write the mesh equations also. So how to find? So first we have to check whether it is planar graph or non-planar. Whether it is planar or non-planar. After checking, we have to assign the loop currents. So it is planar network. So for this planar network, we can easily apply mesh analysis. So this is I1 and this is I2. So I am taking the current directions also here. So here So first I'm considering the loop 1. So I'm going to consider first loop here. So I'm considering the loop 1. So first we have to write the KVL in the first loop. So here I'm applying KVL in loop 1. So what is application? I'm starting from here. So A, so let us take this as A, B, C, D, E and F. So I am considering the first loop, that is A, B, E, F and A. So I am applying my KVL here. So that is I1 into 5 plus. So here this 2 ohms branch is common for first loop and second loop. So while considering first loop, first we have to consider that current is higher compared to the second current. So that means here I am going to take that is I1 minus I2 into 2 minus 10 is equals to 0. So if we can simplify this again, so then we are getting as, so I am separating the I1 terms here. So this is I1 and this is also I1. So that is 5 plus 2 into I1. Next minus 2 into I2 is equals to 10. So if we can simplify this one, so that is 7I1 minus 2I2 is equals to 10. So this is equation number 1. Similarly, if we can apply KVL for second loop also. So apply KVL for second loop. Apply KVL in loop 2. So what is loop 2 here? B, C, D, E, B. So for this loop we are going to apply KVL. So here the first I am taking as starting from here. So that is I2 into 10 plus 50 plus. So here this 2 ohms is common for both loop 1 and loop 2. So while considering the second loop, so first we have to take that current as the highest current compared to this one. So I am going to take that as I2 minus I1 into 2 is equals to 0. So simplify this, rearranging this one I1 and I2 terms, so that we are getting as, so minus 2I1 plus, so I2 terms are here 10 and this is 2, so I am directly writing here. So 12 I2 plus 50 is equals to 0. Or we can write this expression, that is 2I1 minus 12 I2 is equals to 50. So let us take equation number 2. So we have to solve these two equations, equation 1 and equation 2. Then we are getting I1 and I2. So now let us see. So this is the two equations we are getting. So this is equation number 1 and this is equation number 2. So after solving these two equations, we are getting I1 and I2. There's the two loop currents we are getting here. So here the I2 we are getting as negative sign here. So that means here whatever the direction we are assumed here, so that current is flows into opposite direction. So current in the second mesh is negative. So that is actual current is flows into opposite to the assumed direction. So what is our assumed direction here? This is our assumed direction. But what about the current we are getting here? Negative current. So that means here our current is flows in this direction. So that is the conclusions we have to make from this results. Now let us see one more problem on super mesh concept. So by looking at the circuit, so we can see that check that. So here for loop 2 and loop 3 the current source is common here. So just now we said that, so whenever the current source is common for two loops, we are going to apply super mesh concept here. So after that, we are going to find the 3 unknown loop currents. So first, for this diagram, what is asked here? So determine the current in the 5 ohms resistor in the network given below. So what is asked here? So what is the current flows into this 5 ohms resistor with the help of mesh analysis? So from the first mesh, we can write that the first mesh is already given here, the points A, B, C, D, again A. So we have to write, so directly I am writing here. So that is 50 into, this is 10 into I1 minus I2 plus 5 into I1 minus I3. So after rearranging I1, I2 and I3 terms, so that is 15 I1 minus 10 I2 minus 5 I3 is equals to 50. So let us take this equation number 1. This is for first loop. Similarly, for second and third loop, so directly we are not going to apply KVL because the in between these two loops the current source is there. So therefore we have to apply super mesh. So for second and third meshes, we can apply super mesh. So what is super mesh here? So super mesh means I am considering this, I am indicating as a dotted line here. You can apply KVL in this loop only. So we can apply KVL in this loop only. So whatever the dotted line I shown, so in that portion only we have to apply. So coming to this one here, so that is 10 I2 minus I1 plus 2 I2 plus I3 plus 5 into I3 minus I1. So again we have to rearranging the I1, I2 and I3 terms. So then we are getting the second equation also. So after applying the super mesh, so again we have to write the equation for these two loops because it is separated by a common current source is there. So we have to write the equation, that is I2 minus I3. So that is I2 minus I3 is equals to 2 amperes. So you can see here this I2 direction is in this direction of that 2 amperes current source, and this I3 is in this direction, that is opposite to the current direction. So that we can write as I2 minus I3 is equals to 2 amperes. So after getting these three equations, so first, second, third equation, so we have to solve the three equations. So based upon solution of three equations, we are getting the three currents, that is I1, I2 and I3. So what is asked here? He is asked to find what is the current flows to the 5 ohms resistor. So here the current flows to the 5 ohms resistor is the combination of the two currents. What are the two currents? I1 and I3. So that is current flows to the 5 ohms resistor, that is I1 minus I3. So what is I1 here? We are getting 19.99 amperes. What is I3? That is 15.33 amperes. So orally we are getting as 4.66 amperes. So therefore the current flows to the 5 ohms resistor is 4.66 amperes. So this is about the concept of mesh and super mesh concept, and we have seen the problems also. Thank you for today's class.